Okay, so to introduce myself again for the recording, my name's Carol Bailey White. I'm the president of Duval Audubon Society. With us this evening is William Blake with the American Bird Conservancy, and he's going to be talking about the Motus Wildlife Tracking System. Motus is an international collaborative research network that uses coordinated automated radio telemetry to facilitate research and education on the ecology and conservation of migratory animals. Motus is a program of Birds Canada in partnership with collaborating researchers and organizations, including the American Bird Conservancy. A little bit about William. He recently began his work with the American Bird Conservancy as the new Pacific Northwest Motus Coordinator. He has substantial experience installing, maintaining, and advising partners on Motus network infrastructure across the Western US and Mexico. In his new role, William provides key leadership, technical assistance, training, and coordination of the Motus Wildlife Tracking System across the Pacific Flyway region. William will tell us more about this fascinating system and how it's being used to inform bird conservation efforts here in North America. Thank you so much, William, for being with us, and you can go ahead and take it away.
Thank you, Carol. And thanks for having me tonight. I am excited to give you guys an introduction on the Motus Wildlife Tracking System. And I have my email address here on the first slide, and I will also have it on the last slide if you wish to contact me for any questions or follow-ups. So as Carol mentioned, I've been working on Motus for the past 5 seasons, I believe, and just started my job here at ABC. But American Bird Conservancy, we are serving as the United States stewards, I would say, to push the Motus program in the lines of strategy across the United States. And so my supervisor, Adam Smith, is the Motus US director, and we are hoping to continue disseminating the coordination of the Motus program across various regions. So I'm coordinating the Pacific Northwest expansion efforts, but I'm also aware that there is a law under the works for getting some coordinators in the Southeast as well. So I think you guys will be served well in the coming months, if not the next year, with a new Motus coordinator for the Atlantic Flyway. But here we go. So Motus is a program of Birds Canada. I think it's the largest avian conservation-oriented nonprofit in Canada. So similarly to the Audubon Society. And Motus was a program that began in 2013 and has developed throughout the world. It started in Ontario and in the northeastern part of the United States, but it quickly sprinkled through the Atlantic coast and is now found all over North America and is now quickly expanding in Central America and South America. Motus means movement in Latin, and it's a collaborative approach to radio telemetry. So I know that doesn't say much, but hopefully my slides will make more sense here, and at the end of this presentation you'll understand a little better what Motus means and how it operates. This is a recent infographic that Birds Canada, the Motus program, published last year, and it sums up well the variety of wildlife that Motus is able to serve to understand better individual movement of small wildlife. Motus has allowed a revolution in the world of individual tracking of particularly small wildlife, but can be used for any wildlife of any type. But we use it mostly for birds, bats, and even insects, because the tracking capacity allows us to deploy Motus tags on wildlife that weigh under 100 grams, which is a mere 3.5 ounces. And there have been immense successes with red knots in North America, tracking them to winter grounds with monarch butterflies, bats, and also some European species. What I like about this infographic summarizing it all, and I'll use this for our slide, is it also kind of depicts the 3 core principles of how Motus works. The tags, the radio transmitters, the Motus stations, which are the radio receivers, and then the data, how it's processed and how the data is disseminated to researchers. So to begin, let's talk about the Motus tags. So tags are lightweight and they work on the same frequency. So how is that possible? All the tags send little signal bursts that are essentially traveling across the air using a bit of a Morse code, and each signal or each Motus tag or each Motus transmitter sends a very unique Morse signal that is identifiable to that specific tag. And so we can have hundreds, if not thousands of tags all transmitting in the same area on the same frequency, and the Motus receivers can actually identify which tag is which. So once researchers deploy a tag on a bird or a bat or an insect or any wildlife they care to study, they register what individual that is, of which species, and then we can actually track the individual movement of those wildlife. In birds, there's common sense, common ethical rules that you are not supposed to, as a master bander, to deploy any auxiliary marking that would represent more than 3% of that bird's body weight. And so if a bird weighs 100 grams, the band, all the auxiliary marking, and the tag needs to be under 3 grams. So that's just a general rule. There are exceptions, but that just represents how small tags need to be. And especially when you consider insectivores or even any migrants, most birds depend on their ability to fly effortlessly and swiftly through the air to feed, to evade predators, and to migrate. And so the crucial part of how Motus has really revolutionized the world of telemetry is miniaturizing tag weight, tag dimensions, and making it possible for us to not harm birds with those characteristics in order for us to track the birds during their migration. And so I told you about how tags are, we call them coded VHF, because that little electronic signature is that Morse code that then the Motus receivers can detect what tag is which, because they all have their own signature. And so that's thanks to that new technology called coded VHF. And VHF means very high frequency. So it's just a range of radio transmission at which the tags operate. And here in this picture, you can see a typical leg loop harness. It just goes around the legs once it's placed at the base of the bird's back. There are different attachment techniques. This one is very common and considered one of the least invasive techniques. And then depending on the material the researchers use, the birds are typically thought to fall off after a few months to a few years. In the case of this Swainson's thrush, the tag will most likely be deployed for 2 to 3 years before the material starts fraying and falling apart. And I think this tag has a burst for it beeps every 30 seconds. And so this tag is specifically made for long-term data collection for birds that, such as the Swainson's thrush, travel long distance. Researchers can ask the companies to program the tags to beep at different ranges of time. So tags can beep every 2 seconds, or they can beep all the way up to 30 seconds. And the bigger your wildlife at stake, the bigger the wildlife you're studying, the heavier you can put a tag. And so the longer typically that tag can last. But we have 2 competing companies that have their tags work with Motus. And so thanks to this healthy competition between the 2 companies, the companies have really catered to miniaturizing the tags and offering diverse options for the greatest diversity of applications. And so we now have the possibility, both through cellular tracking technologies or through low-tech, to be deploying tags that are either powered by little batteries, or some of the tags also have a solar panel. And so the solar panels can either charge the batteries for perpetuity, for the longevity of the time that tag is on the bird's back, or can be standalone enough to power the tags. And so if you have a little bit of sunlight or even indirect sunlight, some tags can work just with a solar panel without even a battery. And today, there's been, I think in the past year or year and a half, the companies now offer a tag called NanoPin. It's the one in the upper left corner. It's smaller than a paper clip, and it weighs 0.19 gram, which is really small. And so advances that are now allowing us to tag with a little more certainty that we won't be harming as much the wildlife at stake. So you know, some species of dragonflies, hummingbirds, potentially monarch butterflies, and yeah. All right, and next are the Motus stations. These are the radio receiving systems. So the radio tags are put on animals, and maybe I didn't explain this, and hopefully I will by the end of this presentation. But as a tagged bird flies through the air, those tag signals are then received by these Motus stations. So what is a Motus station? There are 4 main parts to a Motus station. There's the antenna array, which are really the ears of the station. There is the mast and structure, the computer parts, and then how you power the Motus station. So first, looking at the antenna array, this is a picture of a busy mast, but I think it illustrates well the couple points I want to make about an antenna array on a Motus station. Often we deploy Motus stations that have directional antennas. So you point the antennas in the direction you hope to be detecting the birds. And by putting multiple antennas stacked on top of one another, you can get detections at different directions. So if a bird is moving north to south and you have 2 or 3 antennas, the antennas facing north will start picking up a bird. And as the bird moves, let's say on fall migration towards the south, then different antennas will start picking up that same bird. But the signal strength will show you that a bird is moving north to south. And then you can input all that data in your analyses to get a direction of movement and more or less accuracy of where that bird might be located. And we install 2 types of antennas for the 2 types of companies that are compatible with Motus. So the CTT technology and the low-tech technology function on 2 slightly different frequencies. And so we tend to install Motus stations that can detect those 2 types of tags. Then you have the mast and structure, and that is really, I think, what people think of when they ask me, what is a Motus station? What does it look like? What a Motus station looks like will really depend on where you put those antennas. So in this case, not too far away from my house, we installed these sets of Motus antennas on an old power pole that was abandoned. So in this case, the Motus station looks like a big wooden pole. However, in this case, we installed around a cattle fencing area a conduit pipe with 1 antenna. And so the Motus station looks pretty bare bones. And then there's also 2 types of computers today people use for the Motus station, either an open source computer that you can build yourself. And so turns out to be a fairly cheap way to assemble your computer with all the parts that are crucial to being able to function and then be registered to the Motus network. Or there's also an integrated system that is a professionally designed board. But both computers, either the open source public system or the integrated board, both work on the same software. It's called a Raspberry Pi, and then you load the software that's working with Motus. And then you have the type of power. So a Motus station can either be working with deep cycle 12-volt batteries connected to a solar panel, and then you let it out in the field, you put it into a case, and so at the end it looks like this. You have the charge controller on top of the batteries there in the bottom left on a piece of plywood, and then you have the computer with all the coaxial cables that are connected to each antenna. Or you can plug that Motus computer directly into an outlet. And so in this case, we just plugged a power adapter right into 120-volt power. So what does a Motus station look like? So on the left, we have a picture of our Veracruz Motus station with a nice kettle of broadwing hawks, Swainson's hawks, and turkey vultures. And that is a tower on top of a hotel. I think it's like a Ron type 30-foot tower with guy wires you can see at the top. And then on the right, you have a more bare-boned conduit mast we attached to a fence post that was somewhat just abandoned. There was no fencing around it. And then we put solar panels right next to it. You can also attach Motus stations in the left to these large silos. So I think these are 70-foot silos, and we attach them directly to the guardrail. And then the picture to the right, that's a wildlife management area in Oregon. You can also install a roof tripod. So 2 different examples, Malheur National Wildlife Refuge and American Prairie Reserve on a Quantum hut. I showed you this picture to the left before to illustrate the antenna array. That's at the Peregrine Fund Center right above the Harpy Eagle enclosure. Or you also have a lighthouse on Cape Sable, which I think was the first Motus station to ever be installed. And then there's different types of remote stations that are set up to, solar panels with deep cycle 12-volt batteries that I've installed. So on the left is the biggest pop-up station I've installed on MPG Ranch, which is in Western Montana. That one was 33-foot tall. You have also a 22-foot mast that I just assembled myself using conduit pipes and cables I found at Home Depot. And then you can even install antennas directly to a T-post. And so it can also be fairly non-invasive, depending on what your research needs are. I was going to show you a progression of the receivers populating the North American map, but I figured for saving a little bit of time, this is the world map of all the Motus receivers, all the Motus stations that exist and are currently active. And all those yellow dots are Motus receivers. And I know the dots are pretty small, so here's a little bit more blown up. The North America, this is essentially where, you know, if people are talking about the Motus network, this is what the Motus network is. And as you can see, because Motus started in Ontario and then trickled down the Atlantic coast, actually there's a very good coverage of the Atlantic coast all over Eastern US and into Florida. And that's been, you know, a crucial part to Motus's success. And then finally, you know, what revolutionizes the world of telemetry thanks to Motus, and what embodies Motus is not just the tags or these automated stations that I forgot to mention too. These Motus receivers, they work 24-hour, 7 days a week. They work all the time, and they are automated, so it can in some ways replace crews and field staff hours going out trying to track animals. You can essentially have these automated stations set up to record constantly, but they can also complement handheld telemetry. So if researchers were interested in getting more accurate locations, or finding a bird or its nest or a roost, or potentially a bird dropped its tag and the researchers wanted to find that particular tag in the field, you could complement Motus station detection with also going out in the field by yourself with a handheld telemetry to find those tags. But the third part is the data and how they're processed for research and conservation. There's a couple ways you can access data. One, the public and researchers often focus on the Motus website. So if you go to motus.org, this will be the first thing you see when you type in motus.org on your research bar. You will find an open, public, and free access to your data by going to the Explore Data tab. And when you open that Explore Data tab, you have a slew of options to start exploring Motus data and make sense of what is actually at your availability as a general public, or as a migrant or bird enthusiast. But in the last few months, Motus has just come out with their Motus data dashboard, which is a mine of information that I'm just starting to explore, and I have not yet discovered all the opportunities and possibilities to explore my own data and data from collaborators. But I'll show you a couple slides. So if you go to the Motus dashboard, this is what you'll see. And this, I think I selected in the upper center of the screen, you see Explore Stations. So specifically looking at stations, color-coded are dark colors being the lowest number of animals detected, to the lightest colors being the most number of animals detected. The clusters of Motus stations that are picking up tags, picking up animals. And so you can see that just by doing this quick clustering for the sake of tonight's illustration, there's a lot of animals that have been detected in the past year in the Northeast US. But we have a slew of different species and different animals being detected all over the United States. And then if you go to that Explore station and you go down you can actually select, okay, now I want to actually see, I'm really interested in, let's say, turkey vultures, and I want to see how these turkey vultures have been tracked using Motus tags. And, not all species are tracked using Motus. and this technology has been used mostly for smaller species, smaller wildlife, such as warblers or sparrows or swallows. In the case of wood thrush, which was an early success story for Motus, you can see the raw data, and this is over the course of, I think, starting September 2017 going through October 2022. There are a lot of points and a lot of tracking lines. So it doesn't necessarily make sense, and you would have to filter a little bit your results, but you can use the Motus dashboard yourself. It's completely free. And so one quick strategy you could use is changing this map into a heat map. And by doing that for this for the wood thrush, you can see that. So in green, the green dots are all the Motus stations that have detected wood thrush in the past. These little white tags are where people are deploying tags. There's also a couple here that are under the heat map. But what you can see is most wood thrush have been detected in the Northeast, starting in Virginia and going up to New York and New Hampshire. And then they are mostly detected where there are a few Motus stations that are starting to expand in Panama on their winter grounds. And so in the case of the wood thrush, you can visualize how many researchers are probably tagging them in the Northeast, but then they all go down to the same winter grounds. And the heat map there in red shows how many wood thrushes are being detected at very few Motus stations. But you can also look at specific Motus stations within the Motus website. So just a couple other ways you can explore data on the Motus website. This is a Motus station in Cordova, Alaska, and you can go directly to that Motus station on the website and look at all the species that Motus station has detected. And you can see there's Western sandpipers, there's even a Dunlin. And if you click view on motus.org, the Dunlin map, you can see where actually this one shows the Dunlin and the Western sandpipers. So it shows how the Cordova Motus station is connected to other Motus stations in the network. And then I also wanted to show you a quick animation. So I spent 5 years studying common nighthawks in Montana, and we had no idea how they were making it to their winter grounds. And what we found is they all go through Florida. So I'm going to show you over the course of 3 years. So that was, I think, our second year when we only had 7 nighthawks tagged, and we didn't really pick them up back on spring migration. Well, I guess we did. And that's our second year. We have a lot more. We had 22 common nighthawks plus the ones from the previous year. And then in our final year, I think we had a total of 44 common nighthawks, all tagged at one location in Western Montana at MPG Ranch. And you can see that most of them, if not all of them, flew through Florida. And so for us, it was always this exciting moment, and probably for you, a less exciting moment, although, yeah, more exciting moment during the hurricane season when you're hoping that things are going to be okay. Right in the middle of the hurricane season, our Montana common nighthawks would just go straight to Florida and then hop over into the Caribbean to join Colombia. And you can tell that some of these nighthawks, they almost appear as if they did not go through Florida, but that could just be a lack of detections. It just means that between Montana and Colombia, we did not detect them. So it doesn't necessarily mean they went right through the Gulf of Mexico. But then I'm not going to elaborate too much on this, but the main way researchers eventually do analyze their data and gain access to their data so that they can filter it and make sense of it is through statistical software. And the most common one that Motus developed in order to send the data to was in R. So R is a statistical software and language that a lot of researchers today use. And once you input the information in R, you can start making sense of your data. So you can start looking first at, are your Motus stations working? So this is just a quick figure. I'm not going to go through all of this, but you're looking at different antenna strength or signal strength at each antenna, and you're trying to see if your antennas are actually detecting the tags you want them to detect. And then as the birds leave the breeding grounds, you can actually track that using, so here are stacked 6 different Motus stations, and as they go south, you know, you can see in the upper figure a bird being detected by 3-4 different types of antennas, all at the same receiver. And then this is the breeding ground. And then at some point in this timestamp, the bird leaves and is suddenly detected at a Motus station at a lower latitude. And then that bird leaves the detection range of that Motus station, is picked up at a 3rd Motus station, and etc. As it goes down in latitude, this tag is being detected at different Motus stations. So there's many ways researchers are able to filter their data and make sense of it. And I won't talk more other than saying that there are aspects of the data that might show up on the map that are actually due to false positives, due from environmental radio background noise that appear to be tag detections but are not. And so it's really important for researchers to really disseminate their data before they can publish. But with that said, here's a wonderful figure that Stu McKenzie and the Motus program at Birds Canada published, and were happy to share with me, showing many different Swainson's thrush, and the color schemes are just different deployment locations of Swainson's thrush on breeding grounds, and how those Swainson's thrush from these different breeding areas, so yellow is one breeding ground, green is a different breeding ground, they were all detected in Colombia. And from that Motus station, when they come back on spring migration, then they all go back to different, they seem to be choosing different migratory routes, but they all go back being detected along the way. And then when you've made sense of your data, you can start also publishing. I think 137 publications have used the tracking information gathered through Motus to make sense of migratory behavior and stopover information. So in the case of gray-cheeked thrush migration, what they found was birds with lower fuel loads, so birds that were skinnier, took longer amounts of time to make it back on spring migration, which makes sense. As a bird is healthier and fatter, birds will be better equipped to migrate to the breeding grounds and ensure a successful breeding season. So that's something that Motus has been able to demonstrate. So with this, I hope you understand a little better how Motus works. And through, I guess, another thing I haven't really discussed is there's no fees to join Motus, so you can create an account if you want. You can host a Motus station. There's no fees associated to sending your data to Motus and registering your Motus station to Motus, to the Motus program. And that data, there's also no fees to accessing that data. So the data is public, and there are educational programs that Motus also is now hosting that allow certain curriculums for schools if schools are interested in teaching about migration to their classrooms. But we can now start using the information we have today to start strategizing for the continuing of that expansion. There are a lot of gaps, a lot of holes in the US and also south of the US that we're really excited today to start filling the gaps with new Motus stations. So if we look more closely at the Southeast network over the next few years, ABC and our partners have secured funding through the US Fish and Wildlife Grant program to expand the Motus network. So in the Southeast, in the next 3 years, this will result in 35 new Motus stations. And I think these will be mostly focused, as you can see in purple, in the Southern Appalachian. So this will also be supporting tagging projects with various partners. And I think some of the species considered will be rusty blackbird, northern saw-whet owls, golden wing warblers. And this grant will also enable us to support partners in yellow. So these will be prominently in Florida. And that's because Florida is a crucial piece of the migration puzzle and a key area for the Motus network to grow. And Florida functions as a migratory crossword, bridging east-west and north-south migration. Florida is a part of 2 major pathways for migratory birds. As a part of the Atlantic Flyway, but the Panhandle and Peninsula function also as an extension of the Mississippi Flyway for billions of the southbound migrants. So these migrants are reaching the Gulf Coast en route to the Caribbean and South America. So roughly speaking, 2 of the continent's major flyways are overlapping along Florida. And then Adam Smith wanted me to share with you that just looking at the shape of the coastlines in the Southeast, you can probably understand how these act as a funnel to migrants, moving north to south through the US into the long, flat, narrow peninsula of Florida. And this geography is similar to what we see in Central America, where migrants are much more concentrated in their non-breeding areas compared with on their northern breeding grounds. The increased concentration of migrants moving through Florida means there's the potential for increased susceptibility to multiple environmental stressors. And so if you look specifically at the Motus data, it demonstrates precisely what the previous slide suggested. Florida Motus stations have detected hundreds of tags moving through the state, representing at least 35 species spread among tagging locations around all of the Americas. So Florida is a key strategic position for the Motus network. An important focus of ABC in the coming years will be to work with partners and identify organizations and individuals to champion Motus, to help us grow the network of the Motus infrastructure around the Gulf of Mexico, in an area where billions of birds endure their intercontinental migratory passage. And that represents 300 species twice a year that use that area twice a year. So a lot of birds. And then on a broader level, Motus is really now, as we talk about local strategy and local expansion, also trying to plan ahead. So they just came out with the strategy to 2030. And within those, within this document, it rehashes what I explained to you today, how we deploy receivers, tags are deployed by researchers, the data is centralized, and then it's a repository, but also a portal for everyone, including educational programs and the general public to reach, in addition to the researchers. And then hopefully that will help us augment what we understand about bird research and increase our conservation potential for birds and their habitat. And this document, you can find it. It's accessible on the Motus website, but it also goes through the vision of what Motus is trying to do. And the four main parts are enacting conservation, pioneering science, but also building community. Every time we install Motus stations and we start tagging projects, especially abroad, it can really build strong intercontinental networks by capacitating locals to take part in really important research projects. And then innovating technology integration with the two companies, both Cellular Tracking Technology and Lotec. We see that companies are eager to tailor their products to serve researchers. And we've seen, I think, just an expansion also in the realm of possibilities in the past couple of years of what was possible before to what is now. Tags weighing under 0.2 of a gram is almost ridiculous to think about. So it's been a great adventure. And with that, I'll take any questions. And on the left here, just some metrics and statistics of what the Motus network is today. So yeah, thanks for listening. My email is in the middle here too.
Thank you so much, William. That is utterly fascinating. My goodness. Yeah, it's a wonderful technology. Actually, we have several questions in the chat that have come in. So I'm just going to go through the ones that a couple of them have already been answered. But we had a question from Carolyn. She says, when you say beep, this was early on when you were talking about how they transmit. She wants to know, is it a sound or is it just like an electronic pulse?
Yeah, it's that's a good question, and it's an electronic pulse, I guess. It's a radio signal. So it's a very high frequency radio signal, nothing that the birds can hear, that the animals can hear. It's very much so like changing the frequency of your radio receiver from one channel to another on FM or AM. We're talking specifically megahertz of frequency, in the range of frequency between 100 megahertz and 400 megahertz.
Okay, cool. That's helpful. Okay, the next question has to do with the cost, and one of the other attendees sort of answered the question too, but I'd like to hear your input. So the question is, are the tags, the cost of the tags, are they really $200 each? And then you have to pay a licensing fee on top of that. The person who asked was saying, how do researchers afford to track anything at all on those prices? How does that work with the financing typically?
Yeah, that's actually pretty spot on. The tags vary between $200 and $300, which is almost as cheap as you can go. If you compare your classic radio telemetry, VHF telemetry that was created in the 70s, which is what most researchers have leaned on to study bird or bat migration so far, the tags are very comparable in price. I think that they might be a little cheaper, around $175 a tag, but that is actually much cheaper than a GPS tag or something like that. You know, taking the example of a golden eagle researcher or a peregrine falcon researcher, or perhaps an elk caller or a deer caller, or someone interested in studying the GPS movement of an alligator, living in Florida, those GPS tags probably cost $2,000 to $5,000 each. So it really depends on, obviously, your question at stake. You do typically need to land on a little bit of financial support in order to track migration. If there are nonprofits or groups, especially in developing countries, that are interested in starting tagging projects and have the difficulty of supplying the full financial support for their project, I think that Motus is always the Motus program is always very happy to try to find ways to write grants and support the grant application of some groups, and potentially even provide the full funding for the tags of those entities. So if there were some researchers interested, but they couldn't necessarily afford the price of the tags, I would encourage to contact me or Adam Smith or Stu McKenzie at Birds Canada to talk options. But it's actually the strength of Motus, the price tag, to so to speak, is fairly cheap in comparison to other types of tracking.
Awesome, thank you. We had a question about how far away or how close does the tag have to be in order to be picked up by a Motus station, and one of the other attendees suggested that it was somewhere between 6 and 10 miles. Is that correct?
That is correct, yes.
Yeah. Awesome. The next question is, do you look for donations of equipment for the stations, like have somebody donate solar panels or stuff like that?
I don't know how to answer that, because I've not faced equipment donations particularly, but I would encourage folks who do have equipment to contact us for potential donation equipment. The solar panels, I just having done a little bit of work with solar panels and battery types, it can get pretty specific to the needs for powering a station year round. So something like a 25-watt solar panel would probably not be strong enough to power a station, but 100-watt would be. So definitely yes, if there's folks out there who have equipment to donate, that could always be useful. But definitely, as far as financial donations, dollar bills and financial support for projects, that is something that a lot of researchers, whether they're nonprofit, universities, or some of our partners, are hoping to achieve in the few years, and ABC is trying to help. So ABC accepts donations, and a lot of our partners do accept donations.
Awesome. One of the attendees wanted to know if you can tell us anything about the tracking station that she noticed in the middle of the Atlantic Ocean.
Oh, actually, let me see. I'm gonna stop my share and go back. 1 second. So there are some islands. Oh yeah. Well, the one I see on my screen corresponds to an island, and I don't know what island that is. I apologize. But we do have an emergent Motus Caribbean team that is trying to expand Motus on many of the islands in the Caribbean and the Gulf of Mexico. And I wouldn't be surprised if Adam could potentially let me know what the story is behind the one in the middle of the Atlantic. So I'd be happy to reach back out to you. the nice thing, if you do go to the Motus website, you can, on the homepage, you will see the map of all the active receivers, and it's an interactive map. So you can literally zoom in and click on that Motus station, and it will give you the name of the PI. And it doesn't give you their contact information, but if you know of them, you could probably get in contact with them.
Interesting. I actually had a question about, well, let me just back up. So I was looking at there's a Motus station here in Northeast Florida at Kingsley Plantation. And so I went on the Motus website and I was looking at the data, and it didn't look like data was being collected anymore. And so I guess my question is data only collected when there's an active research project that's using that? I'm not sure if I'm expressing myself very well, but I didn't see any new data, and I was kind of didn't know exactly how to interpret that.
Yeah, you know, I can't speak for the Motus hosts and researchers who have set up their Motus station at that plant or at the plantation. But it is something with aging infrastructure. Sometimes you do see projects, Motus projects that have aging Motus stations. And now along the Atlantic coast, we have some Motus stations that are 10 years of age or nearing 10 years of age. So there might be something very simple that needs to be fixed. Maybe the Wi-Fi password changed and they just need to go and input the new password for the Wi-Fi network. Without seeing the actual Motus station and looking online, I wouldn't be able to tell you.
I was just wondering if their research project had concluded, and therefore, you know, it was not really collecting any more data. So I wasn't quite clear on that.
Oh yeah, if you see the station on the map, it is an active Motus station or intended to be. So the stations that are no longer in use, and that happens, especially up in the Arctic, they only deploy Motus stations in the summer, and then they take them down before they get covered. They will not show up after a few months on that map. So those are only the active stations. If birds are not flying around, you will not be seeing any data, but it should still give you an update status and tell you the latest date at which those log files came on. So
interesting.
But yeah, there are thousands of Motus stations, and they're all a bit different.
Yeah, I'm sure. We have a question. Do you participate or partner with the Nature Conservancy in the U.S. or the Caribbean?
We do. I can't speak for the Caribbean partnership, and I could ask, but definitely we have strong collaborations in California, for instance, and in Oregon to study Pacific shorebird migration. So yes.
Well, I think that's pretty much all the questions that we have. Does anyone have any other questions for William? I don't see anybody popping anything else into the chat. So with that, I think I will go ahead and conclude our evening. Thank you so much again. That was just absolutely fascinating. And for everyone here, I am, like I said earlier, I am recording this, and I'll post the recording on our YouTube channel within the next few days. I am getting a lot of messages in our chat about how interesting it was, and thank you so much again for joining us this evening. It was a great presentation. We really appreciate it.
Thank you so much. Yeah, I had fun. So thanks for having me tonight.
It was great. Thank you again. Good night, everybody.
Thanks, William. Thanks, everybody.